Hey class, how are you? Hope things are going well. Hope everybody's safe and dry. I was thinking a couple of things might be good to share with you so you can practice a little bit over the weekend so we don't lose too much ground. I think a statistic refresher would be a good idea. So I've created a couple of statistical problems for you to use to brush up on your statistical skills, and then that will give you a good base for what we'll talk about on Tuesday. Let me talk a little bit. What's the best way to do this? Let me see what I've got in PowerPoint. Yeah, this looks pretty good. See if I can make it bigger. Okay, so some basic statistics 101. So we're looking at a normal, standard normal distribution, and if this is a probability distribution, under the curve there's a total probability of 1. So left of the mean there's a probability of 0.5. To the right of the mean there's a probability of 0.5 also. Notice this equation right here. This z is equal to x minus mu divided by the standard deviation. That's the key to a lot of the problems that you'll come across in logistics using statistics. Okay. I wonder, let me make sure that the nomenclature is the same on your final exam, your exam worksheet, and it is. Okay. So looking at this curve, our mean is marked by the Greek letter mu right here. And along this x-axis, there's a point here called x. Okay. Everything to the left of that x under the curve has a total probability. Okay, it's some probability greater than 0.5, and I know that because it's to the right of the mean. Okay, so given a population of data, right, that has a mean and a standard deviation. So this might be, what are the average sales of footballs in the month of November? Okay, you would have an average, you would have a standard deviation. Or what is the likelihood that water's going to stock out when the hurricane hits? You know, you've got a mean of chance of that happening and a standard deviation away from that. Okay, so that's how that works. Now, I think that's about all you need to solve several problems, right? Why don't we do one together? So we'll just make it up as we go. Okay, here's paint. Okay, here is our probability distribution. This distribution has an average of something. Let's say, oh gosh, what is this? These are the number of elephants we sell per year, right? And our average expectation is 50. We think we'll sell 50. And this standard deviation is equal to, let's say, 10. Okay. Keep in mind that if you're given the variance, which is the standard deviation squared, that you have to take the square root of the variance before you can use it. Okay, so a lot of these are word problems, and if it gives you a terms of variance, make sure you take a standard deviation of it. Okay, so let's say our barn for elephants holds 75 elephants. Okay, so I'm going to mark 75 right here. This is going to be my x value that goes in my equation. Okay, so first of all, let me write my equation here. It's z is equal to x x minus mu divided by the standard deviation. Okay, so here's the question. Our barn holds 75 elephants. You know, what is the NF? Let's see. What's the likelihood that we're going to have over 50 elephants at any given time, right? For that to work, we might need to imagine that this average of 50 is equal to the average number of elephants we have in inventory at any given time. Okay, let's say we buy and sell bunches of elephants. You know, we've gone out into the barn about 100 times over the last year, and we've counted elephants. And whenever we count them, we have an average of 50 elephants with a standard deviation of 10. Okay, so we want to know what's the possibility that we're going to have over 75 elephants. Okay, that means I'm interested in this probability under the curve right here. Okay, it's going to be a small probability because our average is way under 75. But in order to calculate that, we have to plug and play. We first get a z value, and that's going to be equal to 75 minus 50 divided by 10. That equals 2.5. And then we go to a z-table, right? There are two ways to look up the probability. On the back of your formula sheet, there's a table. It's like this. I'm not sure if you use these in your statistics class or not, but I'll give you another way to do it. But in the table, you can take that 2.5 value and look up the probability. Okay, so 2.5 probability equal to z of 2.5 is 99.38, I think. That 99.38 is equal to this probability under this curve right here. Okay, so you have to get the probability under the shaded area, you have to take 1 minus 0.99, I think I said 38. Okay, that's going to be a probability of 0.0062, or about 0.62% possibility. Okay, so just to kind of revisit all of that, if we go out and we count elephants in our barn and we have an average of 50 with a standard deviation of 10, what is the probability we're ever going to have over 75 elephants, and therefore we'll have elephants chained out in the backyard? The probability of that happening is 0.62%. Okay, so that's how you do these kind of probabilities. Let me say one more thing. Let's do a new sheet. We don't want to save that. New. Don't save. Okay. Let's say our elephants, we'll use the same example. Hold on, I'm getting a text here. Okay. Let's say that let's say we're building a new barn. Okay, let's say we're building a new barn and we know that we've got an average of 50 elephants with us with the variance. I'll give it to you in terms of variance this time. Variance of 100. And we want to know how big our barn needs to be such that our probability of not filling it up is 0.95. Okay, and that's this area under this whole curve. So we go to our z and we do the equal sign, and we just we plug it in again, right? We put x minus 50. We have to take the square root of 100 to get the standard deviation, so that's 10. And then we just go to our table, and then also I got to remember to show you the Excel too. Go to the table and we look up a z value equal to 0.95, and we get that z is equal to 1.65. Okay, so I'm just going to plug in 1.65 for my z. Okay, so, and then I'll solve for x. Okay, simple algebra. Solve for x, and we get 16.5 plus 50 is equal to x. So our barn needs to be needs to hold 67 elephants, right? Can't have half of an elephant. So we need to take that in consideration. Our barn would need to hold 67 elephants, and therefore we'd have a 95% probability of always having enough space. Okay, real quickly, because I think the video is getting a little longish. Let's pull up Excel. There's two commands that you can use to get those same z values. It is norms dist, and I can put in a z-score like 1.65, and it will tell me the probability, 0.95, or I can hit norms inverse, and I can put in a probability. So let's say I now wanted to make sure, maybe barns are expensive, and I only want a 75% chance that I'm going to fill up the barn. Then I would use this z-score, right? A z-score equal to 0.67. Okay, hopefully that's helpful. On Blackboard, I will put some statistical problems for you to practice. Get comfortable with this, and we'll build upon it for inventory management lecture on Tuesday. Okay, thank you, and everybody be safe.